So we're picking up right where we left off, number 18. And this is actually a section that we recently covered, the early part of chapter 5, or middle part of chapter 5. We never got to the end. Right here, we're talking about this function, and it's specifically talking about relative minimum, absolute minimum, relative max, absolute max, right? So when you look at this value right here, what would you call this? Just let me ask you that. What would you call that? That would be the relative minimum value, okay? So everybody go ahead and label that relative minimum. Now, what do we mean by that? You see, if you zoom in and you just look at it from here to here, this is the lowest point from here to here, right? That's the minimum value, but it's only relative to these X values, from this X value to this X value. It's only relative to this zoomed in picture. But if you look at the whole thing, it's not the absolute minimum. The absolute minimum is over here. So let's actually label this one. I would say absolute minimum, but the answers here, they just call it the regular minimum. So let's just put minimum, and in parentheses put absolute, because that's absolute. This is how I always refer to it, the absolute minimum. Okay, and then what is this point right here? What do we call this? This is the relative maximum. So go ahead and write that down. Now, why is that not the absolute maximum? Because it has arrows. These arrows continue forever going up. That's why, like, it doesn't ever reach a maximum value. It goes to infinity, right? But it does have a relative maximum. That means if I zoom in and I just look at this little piece right here, that looks like the maximum. That is the maximum, but just relative from here to here, right? Because if you zoom out, obviously it goes way higher than that max. Okay, so if you understand that, you'll be able to understand this complicated way of asking this. It says the graph below has blank minimum points. How many actual minimum points does it have? 1. So that'd be a 1. So far there's a 1, a 1. It can't be B or D just based off of that. No B, no D. Okay. How about, it says, how about maximum? Is there absolute maximums? So there is no absolute maximum. That means that there's a 0 here and 0 there. It's possibly A or C. And if you move on, relative minimum points, well, there's only one relative minimum point. And then the last one, well, yeah, so there's one relative minimum, so it's this one, option A. It's really a confusing way to ask it. And there is one relative max, so that last one represents the last one. Okay, so let's move on. Here's another exact question. Do we have any absolute max? No, we just have this relative max. We have this relative max. How about minimums? That is a relative min, and this is also a relative min. Why is that? Because it goes down forever. There is no absolute minimum. It goes down forever. There is no absolute max because it goes up forever. So the graph has how many absolute maximum values? 0. How many absolute minimum? 0. Okay, so you have a 0, 0. You already know it's this answer, option B. Wait a minute. C. Yeah, C. My bad. Because it does have 2 relative max and 2 relative mins. So option C. Let's move on. So number 20, this is where we need to know what we covered with the sum or difference of two cubes formula. And once again, you need to identify that these are two perfect cube terms. And you also need to rewrite it like this to be able to identify the A value and the B value in the formula itself. So what belongs in here? X, that's right. And what belongs over here? What times itself 3 times gives you an 8y to the third? 2y, perfect. So now you know the A value of the formula and the B value of the formula, right? Remember that once you identify the A and the B, now you could rewrite it in factored form as a binomial times a trinomial, right? Small parenthesis, bigger parenthesis. The binomial is going to be exactly the same as this binomial, but without the cubes. So what belongs in here? x plus 2y, perfect. Okay, and then over here on the trinomial, we're going to take this first one and put it squared. So there's an x in there. And then if this was a plus, the middle term is going to be a minus. Hopefully you remember that. And that'll be parenthesis, where you put your first term x in the first one, the second term 2y into the second one. So you have your x and your 2y. And then finally, you have your plus b squared, right? And that b squared in this case is the 2y that goes in there. That's a 2y. And then you simplify it. That's a x squared. That's a minus 2xy. Right here, you just rearrange it. -1 times 2 is -2. Put the x and the y together. And finally, the last part, 2y times itself, that's a 4y squared, positive 4y squared. That's in parentheses. And you have the x plus 2y on the outside. So that's your factored form of this sum of two cubes formula, which would be option A. Yep, option A. All right, moving on to number 21, factor completely. We have four terms. You're supposed to try to pull out a GCF, and you're like, oh, maybe I could pull out an X, an X, an X. Oh, there's no X. Or maybe I could pull out a six, and oh, there's no sixes. So that's when you realize, well, if I split them into two, I'll be able to factor things out. So this is where you factor by grouping. You split it into two groups. So the first group, you're simply going to pull out what's in common in both of these? An X. So you're going to pull out an X. And what would be left over on the inside? X times what gets you back to an X squared? X. And how about X times what gets you back to an XY? Plus Y. There you go. And now the second group, what could I pull out of these guys? A 6. So I'm going to pull out a positive 6 out here. That's a plus 6. What's going to be left on the inside? X plus Y. And that is great because it's the same identical binomial. X plus Y here, X plus Y here. So the final part of factoring by grouping is that you put some exaggerated parentheses and you pull out this common binomial of x plus y. You pull it out here. And I want to keep it color coordinated, those red parentheses with the blue x plus y. I'm pulling that out. And if I pull that out, all that's left is an x. And if I pull that out, all that's left is a 6, right? So here's your final factored form answer, x plus y times x plus 6. And it doesn't matter which way you write it. The multiple choice actually wrote it by switching the two, x plus 6, x plus y. There's your answer, option C. Maybe I should have rewritten it with the correct size parentheses. You have x plus y times x plus 6, but you just switch them. Moving on. So if you flip the page, number 22, that is a part of chapter 5 that we didn't really get to, so we're gonna skip that. Same thing with 23, same thing with 24. We are gonna cover this in January when we get back. Let's move on to 25. This is a piecewise function. These are all linear, which means that you have to write the equations of each of them with its condition using y equals mx plus b. We're looking at graphs from left to right. So technically, we're going to look at this line right here first that has an open dot. Now, this line originally would continue this way forever, right? It would continue this way forever. But of course, it doesn't. It ends right there. If it continued forever, it'd be a horizontal line crossing the y-axis at 2. That would be the equation y equals 2. Everybody should know that, right? But because it stops right here with an open dot at the x value of -1, you have to give it a condition. You would say if x is less than -1. But let's just write down the equation, and let's go over here to the side, and let's write down our piecewise function y equals. And the first one is going to be, here's y equals, there's y equals. So the first one's going to be just a 2, nothing else. So you're going to put a 2 up here. And then you got to give the condition if, and we said it's an open dot at the x value of -1 going to the left. So that'd be is if x is less than -1. That's a open dot because there's no solid line underneath it. Going to the left because it's less than is to the left, greater than is to the right. Moving on to the middle line, I want to do this middle line in blue, solid dot right there going up with the open dot right there. Now, the tricky part about this one, and I'm not sure if this is how they do it on the final, but pay attention to the units. On the X, it's 1, 2, 3, 4, but on the Y's, it's 2, 4, 6, right? So it's kind of tricky. So to get from here to the next nice point, it's actually, see, right here in the middle, it's a -5. So you would go up 1, 2 over 1. Does that make sense? No? Okay, think about this. Maybe this will help you. Go ahead and put a -1 right there. This is going to be a -3 right there. That's a -4. This is going to be a -5. It's missing those values in between. Does it make sense now? Okay, so now if you're at this point and you go up 1, 2, and you go over 1, that'll be the slope up 2 over 1. If you go up 1, 2, and then over 1, that's up 2 over 1. If you go up 2 over 1, it's up 2 over 1. So the slope of this blue line, the slope of the blue line is up 2 over 1, so that's just 2, the slope. Now remember, for a line, you want an M and you want a B. Now, where does this line cross the y-axis? Right here at -3. In between the -2 and the -4, that'd be -3. So the B value, the y-intercept, is technically -3. So the equation of this blue line is y equals up 2 over 1x with the y-intercept of -3. So y equals 2x minus 3. Do we all understand this line? Now, this line y equals 2x minus 3 technically continues forever. So we're going to have to give it a condition between this x value and between this x value. So we're going to write it in the middle part of this piecewise function, y equals. We're going to write the 2x minus 3 as the next one, 2x minus 3. Now we do need to give it a condition. Where's this graph located between the x value of -1 and the x value of +2, between -1 and +2. That's where this piece of the line exists, between -1 and +2. So you're going to say if, and you're going to put that condition there between -1 and +2. Those are the x values in between -1 and +2. And obviously, if you put the -1, the smaller one on the left side and the bigger one on the right side, you're going to have less than symbols because both of them have to open up to the right. Now, please pay attention that this is a solid dot, so this has to be a solid line underneath that inequality, like so. Let's move on to the last one. The last one is also interesting. It's a solid dot right there going in this direction forever, okay? So the question is, how much do you rise? How much do you run? But you got to keep in mind that going up, those units, so there's technically a 1 right there, a 2, this is a 3, that's a 4, this is a 5. Hopefully they don't do this on the final, but they might. So you actually go up 1 and over 1. You could go up 1 over 1, right? So the slope is 1 on this green line. The slope is 1. How about the B value? Where does it cross the Y? Well, it doesn't cross the Y, but if you extend the whole thing, if it were talking about the whole line, it would cross the y-axis. So where does it cross? Instead of going up 1 over 1, let's go backwards 1, down 1, backwards 1, down 1. So you'd be right there. Backwards 1, down 1, you'd be right there. And it does cross at the y value of 1. So the B is also 1. So what kind of line do we have? We have y equals mx plus b, 1x. You don't need to put a 1 in front of the x, plus b plus 1. So you're going to write y equals, there's y equals mx plus b, that's a x plus 1. Now, what about the condition? Well, where does it exist at? Does it exist at -4? No. At 0? No. Does it exist at 1? No. It starts existing at 2, and it does exist at 2 because it's a solid dot, and it exists to the right of 2. So you're going to say if x is greater than 2, and it is a solid dot, so you put a solid line underneath it. And that is the piecewise function. I do recommend you to do it exactly, whoops, sorry about that. Do it exactly the way I did it here, because if you just start looking at the multiple choice answers, it really does get confusing. It's better to just look at it, do one line at a time with its condition, and write your own piecewise function. And then you could identify which one it is, which in this case is option A, I believe. Number 26. This is one of the recent sections. It says describe the end behavior, state the degree, state the whether it's odd or even, state the number of real zeros. Okay, so let's start with end behavior. End behavior, it's as you look to the left, does it go up or down? As you look to the right, does it go up or down? But there's a fancy way of saying that. So if I want to say as I look to the left, I would say as x approaches negative infinity. That means as you look to the left, right? As you look to the left on the x's, you're going to negative infinity. Okay, now as you go to negative infinity, where's your graph at? Is it going up or down? It's going up to positive infinity. So as x approaches negative infinity, y or f of x approaches positive infinity. And then you say, and as, so we already said as you look to the left. Now let's say as you look to the right. How do you say that? As x approaches positive infinity, your y values, your f of x values approach also positive infinity. As you go to the right, it's going up. So it also approaches positive infinity. Okay. If you're confused about this, just say x approaching negative infinity means as you look to the left, x approaching positive infinity as you look to the right. Y approaching positive infinity, that means as you look up. If it would say y approaching negative infinity, that would say as it's going down, right? So I hope that makes sense. That is the first part, describing end behavior. Now you want to state the degree. The degree, it should say the least degree possible. And the degree is based on how many directions the graph changes to. So if you think about it, this is 1, and then 2, because right here it abruptly changes, and then 3, and then 4. So the degree is 4. Once again, 1, 2, 3, 4. 1, 2, 3, 4. That's 4 direction changes. So that's a fourth degree. Fourth degree. It could be at least fourth degree. Obviously, it's an even. Why? Because there's an even amount of arrows pointing up. There's 2 arrows pointing up. So it's definitely even. Well, that's kind of silly because we already knew it was even because it's fourth degree. State the number of real zeros. Real zeros are real roots, are answers, are solutions, they're x-intercepts. So there's 2 real zeros. And that's all you need to know for this question. Now, it is kind of tricky because look how they say it. They say as x approaches positive infinity. What does that mean right there? As x approaches positive infinity. Does that mean look left or look right or look up or look down? What does that mean? That means look right. So as you're going right, what's happening to the f of x, to the y? It's going up. That makes sense so far. Now, if you look at this one, as you go to the right, the f of x is going, I guess that also makes sense. Let's continue with this first one. All right, so as you're going to the right, the y values go up, okay? As you go to the left, the y values also go up. So that makes sense so far. Let's continue with the degree. It is a fourth degree. It's a fourth degree. It's even. We wrote that down. 2 real zeros. The answer is option A right there. Now, if you would have looked at this other one, this means as you look to the left, it's going down. As you look to the left, it's not going down. As you look to the left, it's going up. That's why that one can't be it. So hopefully this makes sense. Option A is the correct answer. Let's look at number 27. A lot of people freak out with 27. They think it's a 3x3 system. Technically, it's a 2x2. Okay. Technically, it's a 2x2. Why is that? Because this third equation is not a 3-variable equation. It's not even a 2-variable equation. It's a single variable. So what does that mean? You could actually solve and you'll have one of your 3 answers. So just take that for z, get rid of the 4 by dividing by 4. Now you know z equals -4. That's an actual answer, one of the 3 that you need. Okay. If you look at your solutions, like there's that z value of -4. It could be this one, right? If you look at, or it could be this one. So you're down to 2 answers, 50-50 right there. But anyways, you have the z. Now, if you have an answer for z, you might as well take that z value -4 and plug it in right there and also right there. That way you get a number here and a number here. You won't have z terms anymore. If you plug in the -4, right here you have a 12, right here, or -12, and right here you have a +12. Then you move those 12s to the other side, and guess what? You have a 2x2 system that you could solve. Let's do exactly that. We're going to plug in x minus 4y plus 3z equals -27. And we're plugging in the z value -4 right in there. We said that that was really a -12. And to get rid of the -12, I'm going to do the opposite, +12 and +12. Sorry, I'm doing a lot of steps right here in one. So what do I have here? I have a x minus 4y equals, that's a -15. And technically, that's your new equation number one that only has two variables, x and y. Let's do the same for the bottom equation. The bottom equation is 2x plus 2y minus 3 times z, where we said z is -4, equals 22. So we know that -3 times -4 is positive 12. And of course, you don't want that plus 12. You're going to get rid of it. So you're going to go minus 12. And we end up with our new equation number two, the 2x plus 2y equaling 10, because 22 take away 12 is 10. So we have 2x plus 2y equaling 10. So this is our new 2x2 system that we're going to solve. How do I solve it? What do I do? Anybody? Multiply the top one by what? By 2 or by -2? -2. So when you multiply the top one by 2, you're going to end up with -2x, positive 8y, and positive 30. And it's still over the same bottom equation, 2x plus 2y equals 10. Now you could combine and cancel the x's. You end up with 10y equaling 40, which means that if you divide by 10, you get y equals 4. So far you have the y value of this 2x2. Let's now find the x value by plugging in the y value of 4. So plug in the y value of 4, I'm going to go for the top one. The top one says x minus 4y equals -15. When you plug in that 4 right there, you're going to end up with x minus 16 equals -15. Then you add 16 to both sides, and you end up with x equaling 1. So we have x value of 1, y value of 4, and the original z value of -4. So 1, 4, -4, where's that at? 1, 4, -4, that's option D right there. So the rest of this, whenever I ask you to simplify with the letter I, the variable I, just remember I is imaginary. And the only difference between an I and a variable X is that if you ever end up with I squared, you have to replace the I squared with -1. So all you would do is distribute the minus sign, that's really a -15, that's really a -21I, and you still have the -12 in front, the +48I. Combine the real terms, wait, that's not an X. Combine the real terms, the -12 and the -15, that'll give you a -27. And combine the 48I, take away 21I, that's a positive 27I, which would be option B right there. Let's move on. So there's a question on the final that I didn't see exactly on this practice final, all right? And the question is something like this, where it says factor, okay? And the way they stated on the final is, which of the following is a factor, right? They're not going to give you the completely factored form on your multiple choice answers, because then you would be able to distribute and see which one actually gives you this quadratic trinomial. So let's go through what we know how to factor. The first type of factoring you're supposed to do is pulling out the GCF, right? So this is on the final. Hopefully you guys are paying attention. What is the GCF of these three terms? 2, that's right. Now, what would be left on the inside? Well, 2 times what gets you back to a 12x squared? That'd be a 6x squared. Okay, and then 2 times what gets you back to there? 7x. And then 2 times what gets you back to there? -5. Okay, so we pulled out the GCF of 2. If you look at the inside, it is a quadratic trinomial. But the bummer part about this is that there's a value of 6. If there was no 6, I could do parentheses xx, think what times what is -5, that if you add together, it's a middle term. But there's a number out here. So when there's a number out here, we have to use that longer process of factoring. I hope you remember. If not, jot down some notes. Step 1 is to multiply a times c. So that's 6 times -5. That'll give you a -30. That is step 1 on this multi-step process of factoring. And we are factoring only the inside blue quadratic trinomial that has an a value of 6. So 6 times -5 is -30. You move on to the second step. Step 2 is to make a list of multiples of that number, -30. So -1 times 30, -2 times 15, -3 times 10, -4 doesn't work, -5 times 6. Those are all the possible multiplication combinations besides changing signs that will give you -30 as an answer. Now, what do we do from here? We start combining 30 and -1. That's a 29. This middle term is not a 29. 15 take away 2 is 13. That's not 13. 10 take away 3 is 7. That is a 7. We don't have to change anything. This is what we want, the -3 and the 10. Now, what is the third step? Where do these numbers go? The third step, whoops, is to rewrite. Third step is to rewrite it as a binomial times a binomial, where the first part of your binomial, if you don't remember, is the ax. And we are talking about the blue one, not the original. Okay, don't go to the original and say that a is 12. The blue one's what we're factoring. We already pulled out the 2. So ax is technically 6x. You put that 6x right here and right there. And what about these blank spots? You fill in the blank spots with the numbers from step 2. You put those numbers right in there. So you're going to have a -3 and a +10. And then the fourth step is that magically divide each binomial by whatever you can, if you can. If you can't, you leave it the way it is. So if you look at that first parenthesis, 6x minus 3, you could divide both of them by 3 and you'll get a 2x minus 1. And if you look at the second binomial, the 6x and the 10, you could divide both of those by 2 and you'll get a 3x plus 5. So the completely factored form is this guy, but it's still missing the original GCF that you pulled out at 2. So here's your factored form answer: 2 parenthesis 2x minus 1 parenthesis 3x plus 5. That is your completely factored form. This is your answer. Now, they're not going to give you the entire answer as a multiple choice option A or B or C or D. They're going to just give you several factors and they say which one is the correct one. So they're going to say something like option A, 2x plus 1. Option B, 3x minus 5. Option C, 2x minus 1. And you would pick option C because that's the one that you see there. Does that make sense? But the actual completely factored form answer is this entire thing right here. All right, well, if you watch these videos, you should be ready for the final.